Hello guys, welcome to the second lecture of Specification B Mathematics at Excel. In this video we will be starting the unit numbers. It's the first unit of your of the O-level syllabus. Alright, and another thing that I want to clarify before we begin is that we will be following the specification very strictly, and the reason is because the specification is such important, such level of importance that we need to give is because specification, they will not ask you any skill or they will not test any skill other than what is mentioned in your specification. Whatever skill set is mentioned in the specification is the skill sets that they are going to ask you. All right, so let me just paste the specification first, specification that they have stated for the topic numbers. Let me just copy it and then I'll just paste it over here. Just a minute, come on. All right, here we have it. The ordinary processes of number manipulation. So this is what the specification states, and then it elaborates more over here, the four operations, the combinations of them by using the brackets. So when we speak about four operations, these are the four operations that we are going to talk about. All right, let me just paste it here. Okay, so the four operations. So the four operations are addition, subtraction, multiplication, and division. These are the four operations that they want you to know. Again, I'm assuming that you guys have come to O-level, so you guys are very much familiar with all these four operations. If you guys are not, addition is for adding, subtraction is for subtracting, multiplication for multiplying, and division is for dividing. All right, again, that sounded like as if, anyways, whatever, that was pretty simple. It was like stating the obvious, but yeah. So this is the second thing that they require you to know, which is the BIDMAS rule. All right, so when we speak about the BIDMAS rule is basically the level of priority you need to give when you are given a question that consists of brackets, indices, and blah blah blah. So many times when you have these kind of questions, you cannot just simply do whatever you wish like. What you need to do is you need to follow the priority list. The BIDMAS is just a mnemonic just to remember the priority list. All right, so whenever you have this kind of mnemonic, what it means, you need to simplify whatever is there in the brackets first, then you need to solve the indices, then you need to handle the division, then multiplication, then the addition, then the subtraction. All right, and many people also teach this way, division or multiplication and addition or subtraction. So again, if you do that, no problem at all, it's completely the same thing. But what I would recommend you is sticking to this BIDMAS rule. It's just to be on the safer side, because sometimes it may work, it may not work, so I wouldn't go for that risk. I would suggest you just, like, rather than people using their own theories, I would rather suggest you guys to follow the law, which is the BIDMAS rule. All right, let me just do a sample question. The sample question will help you guys understand the concept a little bit better. That's what I would do in your situation, that having a question, a temporary question, a sample question being solved. So 3 into 5 plus 2 the whole square minus 10. All right, let me see if it has everything. It doesn't have division, but again, I mean, it's fine. You just need to understand the concept. So as we can see, the brackets is the first one, so we need to solve what is there inside the brackets first. So 3 into 7 square minus 10. All right, then we need to do the indices, which is over here. So again, 3 into 7 sevens are 49 minus 10. All right, now over here, what is the next thing? Division. We don't have division. What is the next after division? Multiplication. We do the multiplication. So when we do multiplication, 3 into 49, that's 147 minus 10. And then again, do we have addition? No, we don't have addition. If we have addition, then we do addition. If there is no addition, we skip that and move to the next one, which is, in this case, which is subtraction. So what we do is 137. All right, this is how you normally solve the BIDMAS rule questions. All right, and this is just like, this particular question is like concentrated on bit mass, but then in your exam hall you will be given questions where it will be mixed up, where you will be given bit mass, then they'll give you quadratics and stuff, so you need to do it that way. So the main purpose is that you need to understand the concept of bit mass so that you can apply it everywhere, because in your paper they will be having question where they'll be checking multiple concepts in one question. Alright, I am supposing this specification is pretty much clear. The first unit specification go pretty fast because it's the very basics. They just clarify what the basics are. The specification becomes a little bit more lengthier as we progress. Again, it's something that we can move through it fast. It won't be a very big issue. Alright, so let's move on to the second specification. What does our second specification state? Let me just copy it. Here. Okay, and then let me just paste it. Just a moment. Yeah. So the second specification states prime numbers, factors, and multiples to include finding HCF and LCM in simple cases. All right, I have the notes ready just before we begin the classes. Because I mean it would be really annoying for me to write in the class. Not only annoying, but it'll consume time. I just keep things ready from before. It's more convenient, and I think it makes the class go a little bit more smoother. All right, so now we need to know three important components when we are talking about this specification, where we will further have to discuss about HCF and LCM. Before we go into that, we need to know three important components, which are the prime numbers, factors, and multiples. All right, I have organized it in a way where it's easier for you guys to comprehend and it's easier for you guys to understand each other better. All right, so factors are basically the number that divides into perfectly into another number. All right, so what do you mean that perfectly into some other number? Let me give you an example. All right, so when we speak about example, now let's say let me just make a little bit more space, just a minute. All right, example. So when we speak about example 12, the factors of 12, the factor of 12 is 1, 2, 3, 4, 6, and 12. All right, and what the definition that I've written, a number that divides perfectly into another number. All right, so when we speak about 12 divided by 2 is equal to 6, so these two are the factor. All right, so any number that divides and gets you the perfect number other than decimal or fractions, then you consider that those numbers are, what do you say, factors. All right, so when I put any one of these numbers, which is 1, I get 12, so 12 is a factor. These two are a factor. And then I put in 2, so 2 6 are 12, so I get 2 factors. All right, these are the factors. They're dividing and they're getting into perfect another number. We call it perfect number, integers. So 3, we get 4, we put in 4, we get 3, we put in 6, we get 2, we put in anything other than that, you will not get the number. All right, so that's basically like we factorized it, we factored it. Many ways to say it, but that's what factors are. Factors are basically the two numbers that you multiply together to get another number. That's multiple, but then factors are like the two numbers that you are multiplying to get it. The two numbers are the factor. All right. Multiple is the result of applying the number by an integer. All right, multiplying the number by an integer. So again, multiple is something that's very self-explanatory, but I still have to explain you guys because it's my responsibility. So basically what you do is 3 into 4, all right, multiplying two whole numbers. You normally multiply two whole numbers and then you get 12. So 12 is a multiple. This right here is a multiple. All right, so yeah, that's what multiples are. Now let's finally move on to prime number. Prime numbers are a number that has exactly two factors. All right, that's the reason why we studied about factors earlier. Prime numbers have only two factors. All right, so when I say two factors, now let's say we know that 2 is a prime number, and there will be students there. You might, if I ask you, is 1 a prime number, then you might be thinking, oh yeah, 1 does not come in any other multiples. Then you are wrong. 1 is not a factor. 1 is not a prime number. That's because you need to have exactly two factors. So 1 does not have two factors. 1 only has one factor, which is 1 itself. So technically 1 is not a prime number, although it does not come in any other table, because many teachers try to explain that prime numbers are the numbers that only come in its own table and does not come in any other table. But in that case scenario, we can also consider that 1 comes in its own table, so we can consider that as a prime number. But no, that is absolutely wrong. You cannot consider 1 as a prime number. That's because prime numbers must have two factors, two exact factors. All right, so now let's say we are talking about 2. So what are the factors for 2? 1 and 2. 2 does not come in any other table, which is valid. Now let's talk about 3. So what are the factors for 3? 1 and 3. Got it? So basically prime numbers are numbers that has only two factors. If it has anything less or more, you do not consider that as a prime number. All right. Now that we got that out of the way, now let's talk about HCF and LCM. All right, let me just copy it. Copy. One sec. Paste. All right, this is our HCF. So HCF means highest common factor. All right, highest common factor. And this method that we are going to discuss about is called the method prime factor tree. All right. Again, there are multiple ways to do it, but this is the most easiest way that I have found. So what you do is you start breaking down the number in prime numbers. All right, let me just elaborate more on that. So first what we did is we have 24, and then we can split 24 into 2 into 12. 2 is a prime number. All right, so we leave the 2. 2 is a prime number, so we leave the 2, we move forward, which is 12. Now again we break down 12 into more smaller fractions so that we can get primes. So we get 2 into 2, which is the 2 that we got from here, and we split it, so we get 2 into 6. All right, and then again 2 is a prime number, so we let it be, and then we have 6. 6 is not a prime number, so again we break down 6. So we broke down 6, we got 2 and 3, and then again we cannot break 3 down anymore because 3 is a prime number. So once you can see that everything is a prime, then that's when you stop. You're like, all right, I cannot go any more further. All right, you do that. You do the same process with the other number that they give you, and now this is the most crucial thing. You take the commons. All right, you only take the commons, multiply the commons. All right, what you do is you just multiply the commons in this case, which is 2, 2 and 3. All right, 2, 2 and 3. These are the common that are coming. So we take them, we take it only once, and then we multiply and we get the HCF, which is the highest common factor in both. Now this is basically what HCF is about. You will be having questions where you will be asked to solve HCF, but yeah, so this is how you normally would solve HCF. There are different ways, obviously. There is no specific way that you solve HCF. Many teachers have many different ways to solve HCF. So if there is another way that you particularly like or particularly feel more comfortable, absolutely go for it. Again, this is the method that I find easier, that I find that students find it more easier as well. So this is again what I teach. If there is any other method that your teacher is teaching, absolutely you feel more comfortable with it, don't even hesitate, go for it. Because else in O levels, the best part is that you are given freedom to do whatever you want. But at the end of the day, if the question is stating that this is a particular way that I want you to do it, that's how you do it. If the question is not stating that you don't have to do it in a particular way, you can do it however you like. But the main thing is that your answer should be correct. All right, so that's what HCF was about. All right, copy. Now let's move on to LCM. LCM is quite interesting. All right, again, we follow the same this thing here. All right, the prime factor tree, the same process. All right, we follow the same process for this one. All right, but here is the catch. When we do LCM and we are following the prime tree factor method, all right, we take the commons only once. We need to multiply all the factors that we get. All right, first thing. But the second thing is we only take the common once and the rest we multiply together. So when I say that, what do I mean? So now let's say 2 and 2 is coming twice. We take it only once. 2 and 2, it's coming twice, we take only once. We get 2 over here, we get 3 over here, we take 2, we take 2, 3, and then over here again there are 2 3s, we do not take the 2 3s, we only take once. All right, so that's how you normally solve LCM. All right, we just take the ones that are common only once, and then you take the remaining and you just multiply and you would get your LCM. Pretty simple. And the reason why I recommend students going from prime factor tree method is because it's easier to remember what to do, because there are other ways that I remember that with the you do with the division and blah blah blah. So what happens is that I've seen in students that they forget it, they just mix it up. But I think this is pretty much hard to mix up, because LCM you just take and everything multiply together. In HCF you just take the commons and multiply together. I think that's much easier to remember. All right, again, it depends on you. Whatever you feel comfortable, absolutely go for it. If there is something that I'm teaching you feel comfortable, surely go for it. If there is something that your teacher is teaching and you're more comfortable with it, absolutely go for it. All right, yeah, now let's move on to the next specification, shall we, which is indices, powers and roots. Copy. Okay, let me just drink some water. All right, indices, powers and roots. This is one of the topics that is very, very important, I would say. That's because this particular topic is connected to many other topics. So I would suggest you guys to give a little bit more attention towards this topic. That's because, again, this is a connected topic to many other topics. So, you know, if you don't miss out on this, you will miss out on those topics as well. So, yeah. No. Okay, are we having enough space? Nope. We can move 2 of these over there. Could have just moved 1, but then, you know, just feels more satisfying. Oh no, we can do this. We can do over here, boom, and then this over here, shall we? No, over here, boom. Yeah, so that looks nice. Okay, so now we are gonna discuss about laws of indices. All right, so now the laws of indices again consist of all of these index notation, index laws for multiplication, division involving integer, fractional and negative powers. We will all discuss it right now. I've color coded it in a very nice way. All the operations are in the dark pink, I don't know, purple, pink, whatever you want to call it. All the values, the x values which you would be having in your exam are in blue, and all the indices are in orange. It's easier for you to understand, especially at this stage. So yeah, whenever you have values, x values, again, when I'm mentioning x, you need to notice that when I'm writing x, both of these values are the same. If I'm writing two variables, x variables, it is not that in your exam hall if you have like a 5 and a 6, you cannot apply this rule. No, it will be absolutely wrong. All right, you cannot apply this rule. When I'm writing x and x, that basically means whatever the value of x is, it should be same with the other one. So if I have 5 and a 5, then I can apply this indices rule, then this indices rule is valid. But if I have two different values, no, I cannot apply it. All right, so I hope you guys understand that part. That's very, very important. All right, now let's move on to the second law, which is the division law. You must have the same values. When it's dividing, the indices will subtract. In multiplication, the indices will add. Again, these are very, very simple rules that if you see it, you'll understand. Now let's say when you guys are having brackets, when it's a bracket, the indices multiply. All right, this is very crucial. Please keep this in mind. Many students forget it. It's a very simple, very silly mistake that students do make. So again, I want you guys to be aware of it, that whenever it's a bracket and there is indices inside the bracket and indices outside the bracket, the indices multiply. All right, so please do not make that mistake. Another law of indices, which is x to the power of 0, whatever the number is, if it is 99, negative 99, whatever the number is there on this the world of maths, the answer will always be 1. If it is power to 0, whatever the thing is, it should answer, the answer must be 1. All right, that's again the law of indices. Secondly, we have the negative indices, where negative integer indices, where if value is negative, like let's say x to the power of negative a, so now let's say 5 to the power of negative 3. All right, so what this technically means, it means that 1 over 5 to the power of 3. All right, again let me just explain that again. Whenever I have a value, let's say 5 to the power of negative 4, when this technically means, what this technically means is 1 over 5 to the power of 4, positive 4. All right, the negative represents a inverse. All right, again if I start speaking more into it, it will become more advanced. I wouldn't rather go into more advanced, rather I would want you guys to understand that if I'm writing 5 to the power of negative 4, what it technically means is that is equal to 1 divided by 5 to the power of that power, positive. All right, so that's one. And lastly, which is I kept the best for the last, this is it becomes a little bit confusing, but as far as my experience with the paper, the only times where I've seen this was like 5 to the power of 1 by 2, 5 to the power of 2 by 3. This is the only cases that I've seen, like not 5, let's say x value, whatever the x value is. This is the only cases that I've seen. Again, there can be different cases, there can be, again, examiner's mood, you never know how they set the paper, it's completely on them. But even if you have this kind of question, always remember that the a is for the bracket outside and b is for the root inside. Now you might be asking, okay, so when we write 5 1 by 2, then where does the 1 go? Absolutely. So in that case, what we do is we just write under root 5. Am I right? That's what we do. But there is a 1, there is absolutely a 1, we just don't write it because it does not have any value, it does not have any meaning to it. So again, there is a 1 over there, absolutely it is there, but again it does not have any value, that's why we don't write it. Okay, so this is the law of indices, pretty simple, pretty self-explanatory. What I would recommend you guys is to write this down several times, and honestly, if you write it once or twice, you will understand the laws. You will just like, it will be as if like you install it in your memory, you will memorize it automatically. It's that simple. Okay, that was the law of indices. Now let's move on to this another specification. We'll do another specification. I think we can wrap it up for today. The reason why I'm brushing over the specification for the numbers specification is because the numbers topic is very, very simple. It's very, very easy. There is nothing much that I would like to say more about this because it's such easy topic. You just, the whole purpose of the numbers topic is for the students to get a basic idea about what are the things that the student must know before he or she gets into the exam. All right, so simple manipulation of surds. All right, I have the notes ready. Just before I join the class, I keep the notes ready. Haha. Okay, so let's copy, paste. Oh no. Did anything cut off? Nope, nothing cut off. Good. All right, now these are the laws of surds. The laws of surds are very much different than the law of indices. All right, so we have exactly 4 laws. All right, 1 2 3 4. I've color coded these as well. The operations are purple in color. I wouldn't know, it's the purple, magenta, whatever. And the numbers are in A, B, orange, and the operation is in blue color. All right. So when we are talking about A and B, as you can see, it is 2 different numbers. All right, 2 different variables means 2 different numbers. When we have this, we multiply. All right, multiply, just normal multiplication, the under root becomes together. But if we are multiplying 2 same variables, under root, the under root vanishes. Just like magic, it vanishes. It's not actually magic, it's just like maths, it vanishes. All right, so again, that's the thing. So these under roots are square under roots. Please keep that in mind. It is not cube root or anything, it's square under root. So keep that in mind. If it is cube root, again the laws are different, but for you guys are mandatory for you guys to know the laws of surds, which are the square numbers. All right. The third thing, which is we call it surd simplification. All right, so when we do surd simplification, what we have to do is first we take the number and we break it down. All right, we break it down. Again, there will be multiple ways that you can break it down, completely up to you, but I would recommend you guys to break it down into square numbers. All right, so when you break it down to square numbers, which is 16 and 3 in this case, 16 into 3. Why is this not erasing? All right, 16 into 3, and then we break it down. Again, we can break down the under roots. And why did we do that? Because over here we remember doing it. All right, so this is basically multiplication, the same thing. You split it up. You can split it up when it's multiplication. You can split it up when it is addition. You cannot. Please keep that in mind. When it is an under root, 16 plus 3, you cannot split up the under root. You cannot write 16 plus under root 3. Nope, this is wrong. You cannot do that. Only in the cases of multiplication you can absolutely do that. All right, we break it down, and then we know that 16 under root is 4. We make it 4. We cannot under root a prime number, so what we do is we just write the value, and this is the simplified version. All right, so this is the third rule that you wanted to understand. And now finally, this is where many students get a little confused, and they make silly mistakes, which is 5 under root 3 2 plus 2 under root 3. If the under root values are the same, that's when you can add or subtract. All right, add or subtract, whatever your case is, subtract or add, you can do it. You can absolutely apply the operation to the whole number that is there at the beginning. But excuse me, if it is not the same, if I have 5 under root 4 plus 2 under root 5, I cannot add this. I cannot. It is not mathematically correct. You cannot do it. All right, so please keep that in mind. If the under root values are the same, that's when you can add them. All right, so that's basically for what we need to understand for the laws of surds. Again, I'm not doing any more practice questions in these sessions. What we are basically trying to do is we are trying to understand the concepts of it. All right, we try to understand the concept. We try to and especially for these kind of topics, I don't want to do any kind of sample questions because it's unnecessary, because these are more theoretical. But when we start moving on to a little bit more advanced topics, that's when I start doing sample questions for you guys to understand. That way you guys can, as you guys can see, the way that I teach the things which are requiring explanation or a sample question, I absolutely do it. The things that does not require, I don't do it. All right, so yeah, this is what we have learned for surds. And yeah, I think there's one more thing left, which is the rationalization. Let's do rationalization. I made the notes till rationalization for this class. So let's just finish rationalization, which will be 5 specification, which is really good amount of numbers of specification that we have done, because I think in numbers we have 1 2 3 4 5 6 11 specifications. So we are almost done with like 40, not even 40, 55% maybe approximate. All right, rationalization is quite short. I will not take more time. Please trust me, just be patient. I know the class became a little bit longer, but please trust me, this is very, very simple. All right, rationalization here, copy. Let me just paste it. Paste. No. Shall we move this a little bit down? Please copy. All right. No. One sec. Just be patient with me. Trust me. Okay. Copy. Delete. Paste. Ha. All right. We got it over here. All right. Now what we do is we need to paste our notes again. We need to take it. Just a second. There was less space, so that's why. Just a second. Rationalization. All right, Now let's begin the topic of rationalization. There will be two cases. They will give you two scenarios in your this thing. There will be two types of question, type A and type B. In the type A, they will give you only a single term. So the way that you need to rationalize a single term. When we speak about rationalization, in the world of maths, we try to avoid keeping under root in the denominator as much as possible. Alright, that's a healthy habit of maths, that you try to keep as less as what do you say, as less as under root in your denominator. All right, so the way that you remove under root in a single term, it's very simple. All right, you basically just multiply the under root. Whatever happens to the denominator also happens to the numerator. So that's the same rule that you apply. We multiply 7 into 7, the square roots vanishes away, and then you get this. But when we have two terms, there is a single thing that you need to remember, that when you must reverse the sign of the integer. Whatever the integer value have, you need to reverse the sign, not of the under root. Under root will be plus or minus, it's a neutral value, but of the integer must reverse its sign. All right, so in this case it was a negative, you make it a positive over here, then you do not quadratic, you just multiply and solve. I am assuming you guys know to do bracket multiplication. So you do the bracket multiplication and then you get the denominator as a 3. When you see that your denominator does not have any under root, that's when you know that you have rationalized the denominator. All right, that's what you call the rationalization of denominator. All right, so this is it for this lecture. I hope you guys understood everything. If you guys have not understood, please drop down your comments. I will absolutely love to help you guys. And yeah, thank you so much for being here till the end. I hope I was able to help you. Thank you.